In this lesson, we'll look at the polarity of molecules. In other words, is a molecule polar or nonpolar? Why would we want to determine the polarity of the molecule? Well, that can tell us something about the molecule's properties. If a molecule is polar, it's going to have two oppositely charged ends, a negative end and a positive end. And if a molecule is nonpolar, it will not have two oppositely charged ends. To determine if we have a polar or nonpolar molecule, we're going to look at the shape of the molecule based on VSEPR theory, and then we'll also look at the polarity of the bonds based on the electronegativity differences. Remember, electronegativity is an atom's ability to attract electrons in a chemical bond. So for example, here's the Lewis dot structure for water. Its actual shape, based on VSEPR theory, is a bent shape, as you see here. We have two oxygen-hydrogen bonds. The oxygen is more electronegative. The electrons will be attracted from the hydrogen toward the oxygen. And there are two lone pairs on the oxygen here. So this end of the molecule is going to have a partial negative charge with all the electrons being attracted up toward the oxygen, and then the oxygen having those lone pairs. That leaves the hydrogen with a partial positive charge. This is a polar molecule. It has two oppositely charged ends, a negative end and a positive end. Now look at BeCl2. The chlorine is more electronegative. It will attract electrons toward itself better than the beryllium. Both chlorines attract electrons with the same ability, so we don't end up with two oppositely charged ends to the molecule. We don't have a positive end and a negative end. This is a nonpolar molecule. In CCl4, we've got chlorines again, attracting electrons toward themselves. They're all evenly spaced, though. And again, no chlorine can attract electrons better than any other chlorine. And so we don't end up again with two oppositely charged ends to the molecule. This one is also nonpolar. With the H2S, though, we've got sulfur, which is a little bit more electronegative than the hydrogen, so the electrons are attracted toward it. And then sulfur also has these lone pairs up here, and so this end of the molecule is very negative, and then down here at the bottom where the hydrogen is, that's more positive. So this one is a polar molecule. And then NH3, nitrogen is more electronegative than hydrogen. Electrons are attracted from the hydrogen toward the nitrogen, plus we've got this lone pair here, and this is a polar molecule as well. So what do we have in common here with our polar molecules? We basically have some asymmetrical molecules with some lone pairs that create some negative charge, negative end to the molecule. And with our nonpolar molecules, we don't have any lone pairs on the central atom, and a more even distribution of charge, more symmetrical molecules. So usually if we see lone pairs on the central atom, we're talking about a polar molecule. However, there are a few exceptions, like this one. This is a square planar molecule. So you have fluorines attracting electrons, but they're right across from each other. And so they kind of cancel each other out in terms of attracting electrons. And then we've got these lone pairs, but they're kind of evenly distributed around that central atom. And so this one is actually a nonpolar molecule, even though it has lone pairs. So in general, if we've got lone pairs on the central atom, we're going to have polar molecules. We just saw one exception, the square planar shape with the octahedral geometry. And then the other exception is the linear shape with the trigonal bipyramidal geometry. So 3 sets of lone pairs here. And then this one we just saw had 2 sets of lone pairs. Hopefully now you know how to determine the polarity of a molecule.